nobody's home, you know that I please, yeah. You look so flawless regardless. Baby, you look like I'm trying to try. Body, you drive me crazy. Body, you're so amazing. I like the way that you move. Ain't nobody matching your groove. I'm just enjoying the view. Oh yeah, yeah. Don't you know that you're
Hello, check. Okay. Hi, everyone. Welcome to this session on Synopsys Flex EDA. Happy to see such a large crowd. Okay, so I'm assuming some of you who are here, you want to get into the details to understand what exactly this is and how it can help you. So let me get going. The idea behind this session was we've been running this platform for about 3.5 years now, and we have a lot of data that we have collected over time, both from our own testing as well as from our customers. And we wanted to share some very specific results because I get a lot of questions around that, and get into details of how many of our customers have been able to improve their tape-out times by several months through this method. Okay, so introducing myself, my name is Vikram Bhatia. I lead product management for Synopsys Cloud Platform, and I have my colleague here with me, Sashi. I'll let you introduce yourself.
Hi everyone, my name is Sashi Obilisetty. I have background, I'm actually Vikram's counterpart in R&D engineering. I have background in pre-silicon, post-silicon, and cloud is here to stay.
All right. So very quickly, so we'll talk about what this Flex EDA model is and how does it work. So what is the platform that supports it, that makes it work? And then we'll get into specific examples of some data we have around spice simulation and timing analysis, and many other design flows, which I don't think I'll have time to explain here, but I have the data to share for you guys to take back and decide if it works for you, and then get into some key takeaways. So to start with, let me quickly explain what is Synopsys Cloud, because a lot of times customers assume when I say Synopsys Cloud, it means I'm competing with the likes of Amazon and Microsoft and Google, and I'm offering cloud. That's not the intention. This is an EDA platform. It's cloud-based, but the idea behind it is you can do end-to-end design with full stack of tools and IP through a browser. And the way we designed this system, it doesn't matter where you're hosting your tools themselves. How do you run those tools, and where you want to manage your design data itself. It could be on-prem, it could be on your own cloud environment that you got from any of the top cloud providers. We have very close relationships with several of them, the top 3 for sure. And then it could also be in case, and especially in the case of startups and smaller environments where you don't have an on-prem setup, then within this platform, we have direct integration in Microsoft Azure, and we can provide compute and storage infrastructure to do that. But the platform itself is all about EDA, right? So our entire tool stack is on this platform. Synopsys IP is directly available, one click from this platform, and you can start from day one. The moment you sign a contract with us, you can start executing on this. Wherever the tools are running, or wherever you want to run your EDA jobs, basically all of the license management happens on this platform. Essentially, this is a complete license management automation platform. And when I say automation, what I mean is a typical EDA license management environment means you'll have a CAD team or at least one person managing the licenses for you, and you have to request or you'll get assigned a certain number of licenses. If you want more, then you have to raise tickets. They will get new keys. They will install the licenses and restart the servers, and then maybe the next day they will give you a green light, or go ahead, now you can start running your jobs with more licenses. This platform doesn't work like that. Everything is self-service and it's on the fly. The moment you want more licenses, there are multiple models. I'll explain that, and the licenses are available instantly for you to use. And typically, CAD managers are the ones who manage this platform for most of the engineers who are using it, but we have designed it in such a way that CAD managers can give access to engineers to also manage their own private environments within this platform to increase, decrease the number of licenses they have. Everything is managed through a portal. It is very user-friendly. It has evolved drastically over the last 3.5 years or so. We are currently in release 8.1, and we do a major release every 6 months and a minor release every month, and the platform improves continuously. So I have today about 150 customers in production. About a third of them have taped out at least once over the last 3 years, and we are adding new customers almost every day. So essentially, the advantage of having this platform instead of your regular on-premises type EDA environment, you get some inherent benefits. One of them is the business model that goes with it, which is Flex EDA, which I'm going to explain in the next couple of slides. The other one is, of course, the speed up you get or the productivity improvement you get with basically doing away with the need to manage licenses or license servers. All you do is access, so you'll get a key to connect, a connect string, and you access license servers which are already hosted. And the environment, so this entire environment fully containerized, auto scales. Today you can run a job with 10 licenses, and tomorrow you can run a job with 10,000 licenses, and the system recognizes that request on the fly and scales on the cloud. So that's why this platform is built on the cloud, and hence the name Synopsys Cloud. What we also did was we built what we call a hybrid solution for specifically customers who only use cloud to burst. And typically this is designed for larger environments where you have an on-prem setup and you have your own Amazon or Microsoft or whatever cloud environment. But for you to burst a job or part of a job from on-prem to that environment is a very complicated setup. Everything needs to be set up in advance, the design data needs to be uploaded, the job needs to be broken down, and how much you'll run on-prem and how much capacity you'll use on the cloud, and based on that you do it. And what we learned from our customers, especially the larger ones, was the biggest challenge for them was to be able to sync the data back and forth, ideally in real time. So we built the hybrid solution specifically for that use case, and we said, yes, you submit as an engineer, you submit the job to the scheduler on-prem, and after that you don't worry. The hybrid solution will automatically first utilize all the compute you have on-prem, and then burst the rest to the cloud, scale automatically on the cloud. The data will move in chunks at runtime, And as the output is generated in the cloud, it's synced back automatically to on-prem in real time. So essentially, by the time the job completes, the engineer has everything it needs as if the job completely ran on-prem, and the engineer would not even see the bursting happening on the back end. And that's the idea behind the hybrid solution that we built. Okay, coming back to Flex EDA. So essentially, there are two models on this platform. You sign a contract with us, and what you get or what you buy from us is what we call Synopsys Cloud Credits. And you have a certain budget of those credits. Now you can decide at the time that you need to, do you want to buy prepaid licenses, which is what we call the cloud subscription license, which is like a traditional EDA license. So you say, yeah, I want 20 licenses of VCS. I know I'm going to always use them all the time. So you can prepay and buy, and you download those licenses right on the portal, and immediately they are available to use. And the terms are predefined in your contract, so 3-month, 6-month licenses, whatever they are. The other option is you do what we call pay-per-use, which is essentially the definition of the Flex EDA business model. In pay-per-use, you don't have to decide how many licenses you want to use, ever. You basically have a design job, and you point it to that pay-per-use license server string in your script. And as the job runs and it needs more licenses, the system automatically enables those licenses. So essentially, you have access to unlimited licenses. And typically, for most EDA tools, number of cores of compute typically determines how many licenses you need. So if you fire that job on, let's say, a 64-core cluster, then based on how many licenses are needed for that tool for 64-core cluster, that many will be checked out. And what the system is doing automatically is, as a license gets checked out, and that part of the job worker completes, let's say, that job in 10 minutes, the system is measuring every checkout of a license and checking back in of the license and the time in between, and that's your actual usage time. And if it's 10 minutes, you're going to pay for 10 minutes for that license. So essentially, all of this is happening in real time, and you can see your utilization live on the portal. The portal has extensive analytics for you to be able to see. Now, the beauty of this is, and many of my customers, I have some examples, have figured out while using it and getting used to the platform, you essentially end up paying the same amount, but speeding your job by 10x, 20x. Why? Because you're paying by the minute. If the, let's say, 10 licenses for that tool take 10 hours for the job to complete, if you scale up to 1,000 licenses, the job is going to finish in that much faster, with the assumption, of course, that the tool is scaling linearly for that number of cores. And if the job is now lasting 10 minutes instead of 10 hours, then you're paying for more licenses, but only for 10 minutes. Hence, your total cost actually might end up being lower for EDA software as opposed to what you were doing earlier with a smaller number of prepaid licenses. And that's what many customers figured out. And you speed up every job over time, and it adds up over the life cycle of the entire EDA design project. Here's the example with a little bit of illustration. So this is for VCS RTL runs. So the number one you see on the bottom is the same job, same design with 2 VCS licenses, and it takes 10 hours to complete. The other one, 5x the number of licenses, and it takes 5x less time to complete. Your total cost is exactly the same. So instead of the job taking 5 hours total, it's taking 1 hour, but you're not paying more. And this scales differently across different tools, because tools are licensed differently, and how the number of cores being used applies to the licenses. And that's the part I want to show. And essentially, what ends up happening is you end up saving so much time, especially for scenarios where you don't have time to wait for overnight or days in some cases. In the case of Fusion Compiler, I know implementation, those jobs might run for weeks sometime. So scaling that up helps a lot to improve overall productivity and overall time to results for your design project. So here's a specific example. This is from a simple 5,000 samples of Monte Carlo simulations for transient analysis running PrimeSim Pro. And we ran this with a small 8-core machine on the cloud. And that requires 12 PrimeSim tokens. And the total job took 380 minutes, which is about 6.5 hours, right? The same job, while running on 64-core machine on the cloud, actually took twice the number of tokens, but only ran for 48 minutes. So net, because you're only paying for 48 minutes instead of 6.5 hours, your actual cost of running this job is 1/4 of what it was from the earlier one. And you also finish the job so much faster, 8x faster at 1/4 the cost using this model. And customers and engineers have figured this out. They have figured out how to leverage this to continuously drive faster and faster results. In some cases, if you have more time to tape out, they use it to run more VCS RTL runs and find more bugs. And in many cases, it just helps them improve the next project and plan better for the next project. So in fact, I have one particular customer who presented at SNUG a few months ago with essentially, they were barely meeting the Foundry shuttle, a smaller customer, and they were able to meet that shuttle because they could speed it up. For the next project, they had planned 18 months, and they were in Series A funding at that time. They knew if they could meet that in 18 months, they could get to their next level, Series B. What happened was, after learning from their first prototype tape out, they actually reduced that time to about 10 months from 18 months. Because they just fixed budget, same budget as before, but they just sped up their jobs using the FlexEDA pay-per-use by-the-minute licensing. And that's how they did it. So this is for SPICE simulations. Let me share another one. This is for prime time, timing analysis. Again, medium-sized design, 40 million, with 200 different timing scenarios. And running the same job on a 400-core compute cluster versus 6400-core compute cluster. And your actual cost goes down by 4x. And you are going to finish that timing job 9x faster. Now, for somebody who is actually doing timing analysis, they know the value of this and how not going over budget and still being able to do it. Now, because you're running it on the cloud, there's an added advantage. You have unlimited capacity for compute also available, and they charge for compute also on a time pay-per-use basis. So essentially, both compute as well as EDA licenses combined, you can speed up your jobs much, much faster. Overnight RTL regressions, just doing one, or you're doing a compile and it takes you overnight to do a VCS compile. Now you can do 5, maybe 8 compiles in one day and not pay more because you're actually using this model. Here's some more data. A lot of this is either from our own testing or from our customers who have shared that data. Different type of tools, different types of EDA workloads, and all of them actually delivering significant improvement. One of the most interesting ones here is library characterization. You see that 52x improvement in time. I have a case study with one of my larger customers, Cisco, that is published. And Cisco came to us. They said, we don't have enough compute. We have 3 months to do our complete library characterization for the entire chip. And here is my budget. Can you make this happen? And we said, yes, absolutely. Instead of that 3 months, they finished the job in 7 weeks. And saved a ton of time, saved a ton of money, used whatever time was remaining to do some more verification, find some more bugs, and help them drastically improve the overall time to results. So that case study, I don't have it as a slide here. It's on my website. Go to synopsys.com/cloud and check it. Across the board, across the entire stack, so I picked whatever examples and data that I actually had that I could share and different types of designs. But essentially, front end, back end, all the way end to end for the entire design cycle, you see these improvements. And typically what we have seen is from an 18-month to 2-year typical design project, most customers are now planning about 12 months if they are using this environment and this platform. Some more examples of customers. Most of these are smaller customers. Cisco is probably one of the bigger ones that I talked about. I don't have it listed here. But I have quotes from customers where they talked about save 30% total time on their project or got results 5x faster and so on. And many of these case studies are published in detail, so please go to my website if you want to download. That's pretty much what I wanted to talk about today, but I'm happy to answer any detailed questions on this platform, the Flex EDA business model, how you can use it, anything. Thank you.
We have 2 microphones in the aisles if you have any questions.
No questions? Yes, please.
Please use the microphone.
Please, I'll repeat your question.
So let's just assume that I'm right now using a license and I use 24 hours a day. So what's my effective per minute charge on that versus the same license on demand? In other words, I'm guessing the per minute on demand license per minute costs more in the assembly. It only works out if I'm physically using the license less than 50%. Otherwise, you're just doing this for free from me, which is very nice.
I'm going to answer the, so by the way, that's the most common question I get for every single customer. My first response question to that would be, you said 24 hours a day, is that 365 days a year?
Yes.
Okay.
That's an example.
Okay. So when we price the pay-per-use pricing, it's a complete separate pricing, right? What we looked at was how much is a license used in 12-month period. And essentially we said to a customer, it should be cost neutral. The decision to buy a prepaid license from Synopsys or use pay-per-use from Synopsys in a 12-month period, it should cost you exactly the same. Now, depending on the tool, some tools are used 80-90% of the time, verification for it. VCS use almost all the time, right? Through the entire project. In the case of VCS, then the pricing would be very similar. What you would pay for VCS for 12 months will be very similar to what you would pay for per minute. Or let's pick prime time, for example. Timing, you would do maybe 3 months in a year. Okay. Prime sim, maybe you're using 40%, 50% of the time in a year. So whatever you're paying for a prime sim license in a year, on a ballpark basis, it'll cost you very similar to do on a per minute basis. So essentially, I want to make sure you don't pay extra, but we also don't charge you less and lose money by providing you this flexibility and this value. Essentially, the advantage of pay-per-use is there because you know, okay, for this kind of job, I'm probably only going to use it for 2 months in a year. I don't want to buy 10 licenses, which is what I can afford from Synopsys for this. So I say, fine, go to pay-per-use. Of course, the cost is not going to be the total 12-month cost divided by the number of minutes in a year. The per minute cost is going to be completely different. But when you will do your analysis and you look at the value you get from the increased time to market, you will see it turns out much cheaper for you. And don't believe me, believe my customers. I have about 11 or 12 case studies published. I publish about 2 to 4 new case studies every quarter. And we are very happy to connect you to those customers. Yesterday we had a session. There was a customer who spoke for us. Talk to them, ask them, how do they use it? Is there value? Is it better to buy prepaid, or is it better to actually do that? And most of them will tell you. I'll tell you what a typical customer does. They will buy a certain number of licenses as baseline. And after that, they will say, if I need beyond that, I'm going to burst with pay-per-use. And they try to keep those prepaid licenses utilized as much as possible, because they have different engineers, different teams, different designs going on. When somebody is doing timing, they're using that. Somebody else is at that time doing verification or characterization. They're using some other tool. And the CAD managers do a very good job of managing these. But once they have a time crunch, you found a bug, it's taking time, and now you're behind by 2 months on your schedule, that's when this really kicks in. And you're suddenly running 5,000 licenses without worrying about, because you know the job with 5,000 licenses is going to cost you maybe $80 to run one job, right? And you're not at all worrying about the number of or the budget that you have to account for if you were ever to buy prepaid 5,000 licenses of a specific tool. In the Cisco example for library characterization, they are running today on, I think, 12,000 or 16,000 cores. And PrimeLib licenses are per core, so they are utilizing 12 to 16,000 licenses. But because it's per minute, every job they decide, okay, for this one I'm going to run 12,000, for that one I'm going to run 3,000 licenses. And that's how they optimize their time and the engineer's time and their budget to make sure that they're able to complete it faster. So I hope that answers your question, but net, of course, I mean, to be very honest, we don't want you to feel you're paying more, and we don't want to lose money. We want to keep it absolutely neutral from a pricing point of view, and that's how all the tools that are available under pay-per-use, that's how they're priced. By the way, not my entire portfolio is not available under this pay-per-use model. It's a very complex engineering exercise to take a tool and convert it to this model where we are actually able to measure the usage. So what we did was we took our top flagship tools which scale, right? So these are where you run batch jobs and you're running hundreds or thousands of licenses, and they are the ones we converted to a pay-per-use model. Many other tools where you are, for example, buying a per-user license, it's almost always utilized. Tools that are interactive, they don't scale, you know, it's like got a GUI. Those are the ones that are not available. But VCS, Prime Time, PrimeLib, PrimeSim, Star RC, most of the engines, so to speak, they're all available under this model. All right, any other question? Cool, all right, thank you very much. Synopsys.com/cloud.
Thank you.
And that concludes our session. We have one more session starting at 4:15. If you could join us again at the Exhibitor Forum at 4:15. That's in just over 15 minutes or so.